Dear students, under the topic triple integrals, here we have problem 4. Now, here the question is evaluate integral 0 to a, 0 to x, 0 to y, x, y, z, dz, dy, dx. Now, we should understand in which order we have to integrate first. The reason is if the limits were independent of the variables, then we would have integrated this function in the order that is given in the question. But whereas here the limits are dependent. If you see, the first inner limit is dependent on y, the second limit is dependent on x, and the other limit is not dependent on any variable. So if you see, these two integrals are dependent, that is, this is in terms of x and this is in terms of y, term of y, that is the variables given in the problem. So we have to understand the variable that is not mentioned in the limit is z. So therefore the first inner integral will be taken as z equal to 0 to y, and so it will be first integrated with respect to dz. But naturally in this problem the order of integration is also given, given as dz in the first step. Anyway, now the second integral, since this was taken as z, another variable that we have to take is y. Since the limits are with respect to x, obviously we have to take this as y, and this limit will be with respect to x, that is x is equal to 0 to a. So this will be the order of integration, and here also we have dz first, dy, and then dx. So we can proceed to integrate the given function in the order that is given in the question itself, because it is given in the same order of the limits of the integral also. So now first we have to integrate with respect to dz. So the outer two integrals remain as it is, so 0 to a and 0 to x. Now the inner integral, when we integrate, we get, that is, we are integrating with respect to dz. So x and y will be treated as constants, so they will come as it is. And what is the integration of z? It is z square by 2. And this is between the limits 0 to y. So 0 to y. And so this remaining part we have to write. So dy dx. And this is further is equal to 0 to a integral 0 to x. Now we shall apply the upper limit minus the lower limit. So when we apply the upper limit at the place of z, because we integrated with respect to z only. So when we apply, we get y square over here. So we see that there is already a y over here, so it gets multiplied and we get x. Y multiplied with y square will be y cube, and the 1 by 2 constant can be taken out of the integral. So I am writing it here, and we have dy dx. Now we shall integrate this function with respect to dy. So this will be equal to 1 by 2 we will write as it is, and 0 to a will come as it is. And now we are integrating xy cube with respect to y. X is a constant in that case, so it comes as it is, and the integration for y cube is y to the power 4 divided by 4. And this is between the limits 0 to x, and we have this dx, so that we have to write. Now this we have to apply the limits over here. So this will be equal to 1 by 2 integral 0 to a. Now here when you apply x, that is y is equal to x over here, that is, when you apply this limit at the place of y, you have to replace it by x. So you will be having x power 4, and that gets multiplied with this x, and it becomes x to the power 5. And this by 4 in the denominator, it can be taken out of the integral. So here I am writing it, and then we have dx. So that is equal to, when you multiply this, it is 4 2 times is 8, and when x power 5 is integrated with respect to dx, it becomes x to the power 6 divided by 6, and from the limits is 0 to a. So on applying the limits, what we get is, so this will be 1 by 8 upper limit minus the lower limit. This a when you apply at the place of x, so it becomes a to the power 6 by 6, and lower limit when you apply, it is 0, so anyway it will be 0 only, so we need not write that. So this will be equal to a to the power 6 divided by 8 multiplied by 6 is 48, and therefore the solution is a power 6 by 48. Hence we have evaluated the given integral to be equal to a to the power 6 by 48. So I hope you would have understood this problem. Kindly follow the next upcoming video lectures for more problems under this topic. Thank you.